This is part 4 of the dynamics lecture for H1 Physics e-learning module. This is the last part of the lecture. So in this lecture, we are going to cover Newton's second law of motion and give you some examples, some applications to that law of motion. So now we have already covered Newton's first law and Newton's third law. So we're left with the final law of motion, Newton's second law. Now, what does Newton's second law state? It states that the rate of change of momentum is directly proportional to the net force acting on a body, and it takes place in direction of the net force. So what is momentum? Momentum is actually the product of mass times velocity. Now we will cover momentum in more detail later on in the chapter, but for now what we need to know is that momentum equals to m times v. Mathematically, we can write that force is equals to dmv over dt, which would translate down to what we have specified before, that force is the rate of change of momentum. So, how can we describe force further? We can always say that force is equals to the change in momentum over the time taken to cause that change. That's how we can put it simply. Now, let us take a look at some applications of Newton's second law. Now, we can apply Newton's second law to a fixed mass to accelerate. Now, we know that equation of Newton's second law, using change of momentum over time, it can translate down to force equals to mass times acceleration. Now, so if you have a specific force and a fixed mass, you can compute the acceleration from that known values. So if you increase the force and with the mass remaining constant, acceleration will increase simply because F is equals to mass times acceleration. Now, there is a applet that you can look at to try changing different values of mass and finding out how it affects the acceleration, or you can keep the mass constant and change the force to find how acceleration changes. Now, another application of Newton's second law. Now, how do we reduce force that acts on a person, let's say in a collision? Now, to reduce force acting on, let's say, a car when it collides with a body, now we know that force is actually the change in momentum over the time it takes to change the momentum. So, in a collision, when a car collides with, let's say, a fixed object, it will collide with the object, and then the velocity of that car will change from a certain value, let's say u, to 0. Now, if the time of collision is very short, you can see the force is the change of momentum divided by the time. So that force will be large. But if you increase the time of the collision by creating a buffer zone in front of the car, let's say, so the car changes from u meters per second to 0 meters per second over a longer period of time. By increasing the time, you can see that the force will be reduced. So these are some of the ways that we can apply Newton's second law to achieve some benefits. Right. Now let's take a look at some of the applications of Newton's second law, how we can use the second law to explain some of the motions. Now, what can we do with the Newton's second law? Now, we can calculate, for example, how much force we need to accelerate a fixed mass from rest or from any existing velocity. Now, we have said before that force is actually the rate of change of momentum, and if you compute that further down, you can get force is actually equals to mass times acceleration. Now once you have this equation, you can see that if you want to accelerate a body by a certain value and the mass is fixed, then you can just use this equation and compute how much force you need to have to get that particular acceleration. Now, together with this part, I've added in a applet that you can use to do some calculations. In this applet, you can see that if you have a fixed mass and if you change the force that's applied on the mass, you can see that the body's acceleration will change, and you can see what would happen if it has already a velocity and you apply a force, how much acceleration it will get and how much faster the body would go. Now, what is one other way that we can use Newton's second law? Now, we know that Newton's second law states that force is the rate of change of momentum. So, we can also write that force is actually the change in momentum over the time it takes to change the momentum. Now, this has a very useful application. Now, if there is a collision between the car and a fixed object, the velocity of the car will change from a certain value, let's say u, to 0 in a very short time. Now, if when the velocity changes from a velocity, let's say u to 0 over a very short time, you can see that the change of momentum divided by the time it takes to change will generate a large force because the time is very short. By increasing the time of collision for, let's say, a car by creating, let's say, a buffer zone, the momentum change is still the same, but the time it takes to change if you can increase the time it takes to change that momentum by creating a buffer zone, the velocity will change from u to 0 in a longer period of time. And that in effect creates a smaller force. And that's one other way that you can apply Newton's second law. So in summary, we have gone through Newton's three laws of motion. The first law, every object continues its state of rest or uniform motion in a straight line unless an external force acts on it to change that state. The second law, rate of change of momentum is directly proportional to the net force acting on a body and takes place in direction of the net force. And the third law, when two bodies interact, the force exerted on body A by body B is equal and opposite to the force exerted by body B and on body A. Now, for the MCQ questions that will come after this, you can use these three laws to answer all of them, and you can review the lecture again if you need to help you understand, to help you answer those questions. That's the end of the last part of the 4-part lecture. Now remember to download the MCQ questions and complete them and submit it to us. That's all for now. Thank you.